Welcome to the trading floor. Now, in the world of Cambridge computer science, time is your capital and marks are your profit. Every single second you spend writing code or analyzing an algorithm in that exam hall is an investment. And today, we're talking about split-second decisions to ensure you invest your time exactly where the marks are highest. Whether you are taking syllabus 0417, 0478, 0983, 0984, 2210, or the advanced 9618 AS&A level, algorithmic thinking is the absolute backbone of your success. But time and time again, I see students leave easy marks on the table when they're confronted with complex, multi-layered logic problems, specifically nested if statements. I want you to picture two candidates right now. Let's call them Alex and Sam. They're sitting side by side tackling a brutal past paper question. Alex is overloading the page with raw computer science facts, defining what an if statement is, but providing absolutely zero actual analysis. Sam, on the other hand, is rushing in a panic, completely missing the specific command word requirements and just writing sloppy pseudocode. Both of their papers are coming back covered in red ink. Today, we are going to fix that. We are transforming how you look at exam questions, using the exact strategies examiners wish every student knew. Look at this. We are starting off with a massive, flashing warning straight from the principal examiner reports. This is the exact trap Alex fell into. The report says, quote, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario." This single mistake costs students a massive amount of marks every single year. You can memorize every single line of pseudocode in your textbook. You can know exactly how a nested if statement operates on a theoretical level. But if you do not link your logic directly to the scenario Cambridge gives you, you are going bankrupt on that paper. Context is quite literally everything. You have to prove you can use the tools, not just name them. So, to ensure you secure those top marks, here is our roadmap. We'll start with the nested if challenge, then look at the procedural framework, unpack the method mark strategy, reveal top examiner warnings, and finally, evaluate algorithm quality. Let's jump right in. Section 1. The Nested IF Challenge and Conquering the Cognitive Domains. Let's look at exactly what Cambridge is trying to test when they throw a complex logic problem your way. It is never just about writing code. It's about how your brain processes the problem. The syllabus specifically targets distinct cognitive domains. What does that mean for you? It means you cannot just rely on rote memorization. You have to actively apply your knowledge. Look at the breakdown here. We have knowledge and understanding, application, interpreting complex binary representations, and critical analysis. What's really interesting here is the inclusion of interpreting those complex binary representations alongside things like nested if logic. The cognitive load absolutely spikes. Examiners want to see if you can untangle that complexity systematically through critical analysis. This is where command word decoding comes into play. If the command word is evaluate, they don't want a description. They want you to weigh the pros and cons of the logic. If it says trace, they want you to manually walk through the algorithm. Sam missed these command words entirely and lost 20% of the paper's value in the first 10 minutes. Don't be like Sam. And this brings us to a crucial concept. Top-performing students develop what Cambridge calls a connected conceptual understanding. This is the absolute holy grail of computer science revision. It is the mastery of fundamental principles that you can seamlessly transfer to entirely unfamiliar contexts. It is what allows you to confidently sit down on exam day, look at a brand new, bizarre scenario about a factory robotics system or an automated banking network, and know exactly how to structure your nested conditions. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. You need to build this conceptual bridge so that no matter what crazy scenario they throw at you, your brain instantly recognizes the underlying algorithm required. Section 2. The Procedural Framework. Let's break down the deconstruct, solve, evaluate methodology. This is your systematic blueprint for consistency under intense exam pressure. Let's look at the 5 pillars of your problem-solving process. First, identify the given information. You need to be highlighting those variables and constraints the second you read the prompt. Second, break the problem into logical steps using decomposition. Third, solve it systematically, constructing your nested conditions one layer at a time. Fourth, check your logic for reasonableness. Ask yourself, does my if statement actually make sense in the real world? And fifth, make justified recommendations. Now, how do top students actually structure this on paper? They use the PEEL framework: point, evidence, explanation, link. If you use PEEL, you encode your algorithmic thinking into a clear story that examiners can easily follow. Think about Alex and Sam. If we guide them to rewrite their answers right now, Alex stops dumping raw facts and instead makes a specific point about the nested if, provides evidence from the pseudocode, explains the logic flow, and links it back to the robotic arm scenario. Suddenly, the red pen marks turn into green check marks.
You can literally see their mark potential shoot from 0 to 100% just by changing the structural approach. Moving on to Section 3, the method mark strategy. This is all about earning points for the process. Listen closely, because in Cambridge Computer Science, the journey is often just as important as the final destination. Marks are heavily awarded for the process. Examiners actively award method marks for your procedural steps and clear working. If you just jump straight to writing the final code and you make one tiny syntax error under pressure, you might lose everything. But if you document your systematic analysis, if you show your trace tables, if you map out the logic gates before writing the nested if, you build a massive safety net of marks. You have to show them how you got there. It is like an insurance policy for your final grade. This directly feeds into your key algorithmic thinking requirements. You need to demonstrate step-by-step decomposition, appropriate data structure selection, efficient code implementation, and rigorous testing and verification. For example, if your nested if statement is sorting through arrays or verifying sensor data, you need to state exactly why you chose those structures. By demonstrating these key skills, you capture those crucial method marks, even if your final code output has a minor stress-induced flaw. Okay, we are about to head into our interactive workshop where I put you to the test, but first, stop scrolling, subscribe to our YouTube channel Ace the Exams, @AceTheExams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back into it.
Section 4. Top Examiner Warnings. These are the insider secrets from the very people grading your papers.
According to the official examiner reports, there are exactly 3 major, repeated mistakes that candidates make over and over again when dealing with nested if statements. I'm putting 60 seconds on the clock right now. Look at any complex computer science data source in your past papers. Scan it. What is the core trend of failure? The core trend is that students rush the logic. Time's up. Let's see exactly what those 3 fatal errors are so you never make them.
Here are the top 3 mistakes straight from the principal examiners. Number 1, forgetting to check overflow and edge cases in your logic. If a system only holds 100 users, what does your code do when user 101 tries to log in? Number 2, forgetting to verify boundary conditions. This is a massive one. Did you use greater than when you should have used greater than or equal to? In a nested if statement, those single keystrokes change the entire flow of execution. Let's do another quick challenge. Find the flaw. Imagine a student wrote this: if temperature is greater than 50, trigger alarm. Else if temperature is less than 50, run fan. Do you see the flaw? What happens if the temperature is exactly 50 degrees? The system does nothing. That is a boundary condition failure. And number 3, which we mentioned at the start, the absolute biggest offense is providing generic answers, not specific to the context.
This comparison brilliantly illustrates the difference. A generic answer just explains what a nested if statement does theoretically. It's like reading a dictionary definition. It completely ignores the exam prompt. A context-specific answer, however, explains exactly how the code solves the specific scenario provided in the question. Generic answers bleed marks. Context-specific answers prove you can actually engineer a solution for the real world. Okay, 30-second speed writing challenge. I want you to mentally write one perfect Peel paragraph right now. Point: nested ifs allow multiple condition checks. Evidence: the prompt's temperature threshold. Explanation: the inner if only executes if the outer if is true. Link: this prevents the cooling fan from activating unnecessarily, saving system power. Boom. That is how you write a high-scoring paragraph. Finally, Section 5. Evaluating Algorithm Quality. We are moving from basic application to critical analysis. When you are asked to evaluate a solution, you cannot just say, yeah, it works. Evaluating the quality of your algorithm means you must systematically analyze 3 specific factors. You need to look at time complexity. How fast and computationally efficient is your execution? You must look at space complexity. What is the memory footprint of your chosen data structures? And finally, edge cases. What is their ultimate effect on the overall performance of the system? This is what true analysis looks like. This forms part of our ultimate success blueprint. 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix. You invest your time in evaluating these 3 criteria heavily because that is where the A-star marks are hiding.
The traits of top-scoring evaluative candidates are incredibly clear. They don't just write a nested if block and move on to the next page. No, they consider multiple potential solutions. They analyze the trade-offs.
Maybe your logic is faster, but it uses significantly more memory. They acknowledge technical limitations. And most importantly, they justify all their design decisions with concrete evidence from the exam prompt. They treat the exam like a true software engineering brief. Listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having the ultimate strategy in your back pocket. So, as you close your notebook and prepare for your next paper, leave yourself with this final question. Are you just solving the problem, or are you actively evaluating the trade-offs? By shifting your mindset from a simple coder to a critical evaluator, you will absolutely master the critical analysis needed to conquer the Cambridge exams. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every single comment. Like and share this video with a study partner right now. Ace the Exams. Your Cambridge success starts here.